Imagine a world where the mighty rivers that power our cities and feed our fields are silently waging war on the iconic salmon that have swam through them for generations. Now, thanks to groundbreaking space technology, we're getting a front row seat to this aquatic drama. But here's where it gets interesting. What if we could peek into the hidden lives of these waterways from orbit, decoding temperature secrets that could save entire fish populations? That's exactly what a team of innovative researchers has done, using over 4 decades of satellite data from NASA and the U.S. Geological Survey's Landsat program to monitor river temperatures and give dam managers a powerful tool to protect salmon fisheries. Let's dive in and explore how this cosmic perspective is reshaping water management in the Pacific Northwest, and perhaps beyond. The Columbia and Snake Rivers, weaving through the Pacific Northwest, are dotted with nearly 20 massive dams. These engineering marvels serve crucial roles. They control floods, generate clean hydroelectric energy, and supply water for thirsty crops. Yet, they dramatically alter the natural rhythm of the river's flow, creating challenges for the ecosystem. In a fascinating study published in Water Resources Research, scientists harnessed surface temperature data captured by Landsat satellites to track warmth levels both upstream and downstream of these dams. For newcomers to this topic, Landsat satellites are like orbiting thermometers, taking infrared pictures of Earth's surface to measure heat. Think of them as high-tech cameras that help farmers optimize irrigation or ensure food production stays efficient. The findings revealed that warmer water spilling downstream from dams puts immense stress on salmon, forcing them to swim harder and faster, which can exhaust them and even lead to mortality. To tackle this, the researchers created THORR, short for Thermal History of Regulated Rivers, a clever tool that analyzes this satellite data to guide better dam operations. And this is the part most people miss. THORR isn't just a passive observer, it's a proactive ally in conservation. As Aaron Urquhart, program manager for NASA's Earth Action Water Resources Program, puts it, NASA's dedication to unraveling Earth's freshwater mysteries shines through in tools like this. By turning years of satellite observations into actionable insights, the agency is directly supporting communities and industries reliant on these vital resources. The study, backed by NASA funding, offers dam operators real-time updates on river temperatures, allowing them to tweak their strategies for healthier outcomes. Faisal Hossain, a civil and environmental engineering professor at the University of Washington and a key author of the research, breaks it down simply. When water overflows from the top of a dam's reservoir, it's often heated by the sun's rays, turning into a stressor for salmon. On the flip side, releasing water through the dam's turbines pulls from cooler, deeper layers, which can chill the river downstream and give salmon a fighting chance. By smartly choosing discharge methods from lower reservoir depths, operators might help salmon populations flourish, potentially cutting down on expensive fixes like habitat restorations or fish ladders that Hossain mentions. Historically, using satellites for river temperature monitoring was tricky. Clouds could block views, and rivers are so slender compared to a satellite's wide-angle lens that details were easily lost. Enter the University of Washington's team, who deployed a machine learning algorithm trained on 42 years of Landsat thermal images. They fed it real-world data from temperature sensors along the Columbia River basin, plus info on weather patterns, local land usage, nearby ground temperatures, and even elevation. The result? A robust tool refined with input from the Columbia River Intertribal Fish Commission, ensuring it's not just accurate but also practical for on-the-ground users managing fisheries. We're teaming up with those who actually use this data to make our research practical, Hossain emphasizes, highlighting a collaborative spirit that's key to real-world impact. Now, here's where things might spark a debate. Could this improved visibility into water conditions reshape fishing rules? Angela Forrestal, a staff officer with the Pacific Fishery Management Council overseeing the Salmon Fishery Management Plan, explains that the council annually crafts regulations based on the latest science. If a salmon population dips to overfished levels, they draft recovery plans factoring in factors like temperature impacts. Tools like THORR could seamlessly integrate into these models, offering a clearer picture of how river heat affects salmon numbers. But is this a game changer, or just another layer in an already complex system? Some might argue it's a step toward over-reliance on tech, potentially sidelining traditional ecological knowledge from indigenous communities, though the study worked closely with tribes to avoid that pitfall. What do you think? Does balancing technology and tradition offer the best path forward for our rivers? Looking ahead, THORR is designed to sync with data from the Surface Water and Ocean Topography (SWOT) mission, a NASA-NEAS collaboration with input from the Canadian and UK space agencies. SWOT measures water flow in streams at 6.2-mile intervals, matching THORR's precision. Meanwhile, USGS scientists have mapped lake temperatures across the U.S. using Landsat and are now eyeing rivers. While the Columbia Basin served as THORR's proving ground, its approach could apply to other waterways worldwide. The code and datasets are open source, empowering anyone, from hobbyists to policymakers, to monitor freshwater using satellites. In wrapping up, this blend of space-age tech and river science opens doors to smarter water stewardship. But what if we expanded this to more rivers, potentially conflicting with industrial needs like hydropower? Do you believe innovations like THORR could revolutionize environmental management, or are there downsides we're overlooking? Share your opinions in the comments. Let's chat about the future of our precious waterways.